Hello and welcome to this week's episode of Whether or Not. I'm your host, Joe Ruch, here with our forecaster, Salix Iverson.
Hi, Joe, and welcome back from break. Did you do anything fun or interesting over the last month?
Well, I spent my first half of that month working, and then I settled down a bit, relaxed, caught up with some family, enjoyed some time outdoors, went skiing up in Vermont. So really just tried to settle down as much as I could. How about yourself, Salix?
I also got to enjoy some time with family and spend some time outdoors as well. I was able to go into the north woods of Minnesota near Lake Superior, and I even tried snowshoeing for the first time.
That sounds like a lot of fun. And to start this week's show, we're going to get into nature in the news. And this week, I'll be talking about Earth's rotation and how it impacts the length of days, as well as the impact of water chemistry on lightning.
I will also have nature in the news stories this week on billion-dollar climate and weather events in the United States during the year of 2020, and record-breaking temperatures in Siberia this past year, leading to the discovery of an intact woolly rhino. Also in this week's show, I will be interviewing the newest member of the Whether or Not team, Michael Jablonski.
And now, time for nature in the news. Earth was in a rush to bring 2020 to an end, as we experienced just last year alone 28 of the shortest days ever recorded. Hopefully, as we usher in the new year, brighter times are ahead. Earth completes a rotation every 24 hours or 86,000 seconds, but this is not always an exact value, as many factors can impact this, such as atmospheric pressure or ocean currents, just to name a few. While these factors only result in a millisecond difference, these milliseconds add up enough to knock off an ultra-accurate atomic clock out of sync with the astronomical time. Because of this, dating back to the 1970s, scientists would add a leap second at the end of June or December when required. Time was added because Earth's rotation tended to be slower. The planet broke the record for the shortest astronomical day 28 times last year alone. And as we do head into 2021, the slower days look to continue, as each day will be 0.05 milliseconds shorter.
It's not a surprise that 2020 was an above-average year for weather and climate impacts because of the record-breaking wildfires on the West Coast and a record number of named storms during the Atlantic hurricane season. To determine just how impactful 2020 was on our communities and our economy, scientists at Climate Central and emergency managers met to discuss billion-dollar weather and climate-related disasters. What they discovered during their discussion was that 2020 is the sixth year in a row where the United States was impacted by 10 or more billion-dollar disaster events. Even more so, extreme weather events are being amplified by climate change. According to meteorologists at NOAA, the most impactful weather and climate events for the first 9 months of 2020 were the West Coast wildfires, drought in the western and central United States, hurricanes Isaias, Laura, and Sally, and Central Plains severe weather events. The cost of 2020's climate and weather events in the United States was $46.6 billion and 188 lives were lost. As we look ahead to the future, the most important discovery from this analysis is that developing resilience to disasters and mitigating climate change are the most important tasks to complete.
Researcher Mustafa Asfer was investigating the impact of lightning on water chemistry when he actually discovered water chemistry has an impact on lightning. While only 10% of lightning bolts occur over the ocean, these few bolts that do occur are far more intense than those that occur over land. To take a deeper look into this, an experimental storm box was set up where salt samples were taken with a variety of saltiness. Discharges over the least saltiest sample were 1.5 times brighter than flashes over wet soil. Discharges over the saltiest sample were nearly 40 times brighter than that over the wet soil. The research team thinks that positive and negative ions that salt splits into the water helps conduct the electricity. More ions means a brighter flash. It is important to remember, however, a small box is not equivalent to the actual lightning bolts occurring in Earth's atmosphere. This is just a step in the right direction.
The Siberian Arctic is melting due to climate change and experienced well above average temperatures during the year of 2020, which we covered in a couple of stories on last season's Whether or Not. Back in May of last year, temperatures soared to above 100 degrees Fahrenheit in one small Siberian town. One large consequence of rising temperatures in this region is the melting of permafrost, or solid soil that has been frozen for a long period of time. The melting of permafrost has a number of impacts, such as the release of methane into the atmosphere and new scientific discoveries. Recently, scientists in Siberia have discovered a well-preserved woolly rhino that died over 20,000 years ago. The remains of the woolly rhino were found almost 15,000 years after the species were believed to become extinct. This woolly rhino is not the first to be found in the Siberian Arctic. In 2015, another rhino of the same species was unearthed and was the first woolly rhino to be discovered. As temperatures continue to increase around the world and in this region, more extinct creatures may be unearthed. Hello, everybody. I'm here with our newest member of the Whether or Not team for this semester. Would you like to introduce yourself?
Hello, my name is Michael Jablonski. I'm happy to be here.
So, Michael, what year at Penn State are you?
I am a junior at Penn State.
And what option in the major? So, what are you interested in going into once you graduate?
I'm a meteorology major, of course. I'm looking into the branch of forecasting and communications.
Cool. And where are you from?
I am from Easton, Pennsylvania, which is about 3 hours east of State College.
And is that one of the reasons why you were able to pick Penn State as a program and specifically meteorology?
It definitely helped to be able to be at an in-state school, but I mean, I also do love Penn State for its meteorology program, as well as the great community that you get to be a part of.
Cool. And did you do anything fun over winter break, since this is our first episode airing after that month and a half we've been away from school?
Can't say I've done a whole lot over the winter break, mainly just spending time with family, which for me is plenty enough.
Perfect. Well, thank you so much for joining our team this semester at MJ, and we hope to see more of you.
I look forward to being a part of it.
Hello, I'm student meteorologist Salix Iverson with your Central PA forecast. We had a pretty dry and mild start to our week this week, but we will see some more active weather as we head into Friday of the weekend. So taking a look at our setup for this upcoming weekend, we'll see we have a low pressure sitting over the upper peninsula of Michigan, and that's going to bring this cold front and this warm front into our area, and that's really going to lead to a lot of precipitation of mixed forms throughout much of the East Coast and the upper Midwest. You can see snow impacting much of Indiana, parts of Ohio, and all of Michigan, with switching over to rain heading into the parts of eastern Ohio and western Pennsylvania, and we may see some snow showers here in State College. Looking ahead towards Saturday, if we want to see, the low will move off to our east and be impacting much of the northern northeast parts of Vermont, New Hampshire, and Maine. Maybe sticking around a couple of snow flurries, especially early in the day on Saturday, but most of the snow will stay to our north at that time. Looking ahead towards Sunday, we won't be having too much impacts happening on Sunday, mainly a mostly sunny or mostly cloudy sky in State College, and we have another low pressure system moving its way into our area by Sunday. Looking at our forecast for this weekend, we can see for Friday we'll have a high of 41 degrees, some clouds, and a chance for some showers. Heading into Friday night, however, we'll drop down to 28 degrees with a chance for some snow showers overnight. And then heading into Saturday, 34 degrees for our high and mostly cloudy. And then by Sunday, we'll have another high of 34 degrees in a partly sunny sky. And now we'll bring it over to our very own Ryan DePhillips, who has a feature on Rossby wave research at Penn State.
In many ways, the atmosphere around us behaves like a fluid. Ocean waves that begin to crest at the beach are analogous to a unique set of atmospheric waves called Rossby waves. Dr. Kevin Bowley studies the similarities between the two as his core research revolves around large-scale weather patterns known as synoptic meteorology.
These waves that are propagating their way inshore, eventually they reach a point where they kind of slow down a little bit. And when they slow down, they kind of stack up and they eventually crest and break and kind of lose their shape overall. And the same thing happens with our waves in the atmosphere. So that's kind of at its core what a Rossby wave breaking event is.
Bowley's most recent synoptic research topic revolves around Rossby waves, which form from areas of high pressure and low pressure. According to Bowley, Rossby wave breaking events can simultaneously deplete and form large amounts of atmospheric energy for weather systems to tap into.
If you flip that question around, if we have storms that can deplete energy, do we also have storms that can increase the energy? And what we found is that there's not necessarily storms per se, but certain patterns. This idea of Rossby wave breaking can actually have a process that leads towards an increase in that energy at the exact same time scale.
When Rossby waves rotate counterclockwise, rising motion can occasionally cause intense mid-latitude surface low-pressure systems like nor'easters to form. Alternatively, when these waves rotate clockwise, sinking motion can result in intense high-pressure systems. This can result in Rossby wave blocking events where prolonged heat waves and suffocating air quality can occur. When Bowley pursued his PhD, he studied zonal available potential energy, which describes how large changes in temperatures over a region can create more atmospheric energy. This energy originates from Rossby waves and have been known to fuel some of the most notorious synoptic scale storms in the northeastern United States. For example, the March 1993 superstorm dropped 20 to 30 inches of snowfall throughout central Pennsylvania.
That happened to be in a scenario where we had anomalously high or abnormally high amounts of available potential energy, and that storm very heavily depleted the energy of the atmosphere.
Also, Bowley plans to apply his research towards studying climate models. His goal is to see the evolution of Rossby waves from previous years and compare them to model projections.
My hope is that my work and the work that we do here in the department will help to prescribe how people can make informed decisions, how they can make smart decisions about how things are changing, how that's going to impact their day-to-day, but also how it's going to impact the day-to-day of whether or not their package will arrive, whether or not their car will be able to work the way it does.
Ultimately, Bowley hopes that his research will help improve how models predict areas of intense high and low pressure systems. An increased understanding of these future events is critical to help people be more prepared. For Whether or Not, I'm Ryan DePhillips.
Hello, I'm Salix Iverson, back with your extended forecast. We'll see some rain and snow mix on Friday before having a more mild rest of our weekend for both Saturday and Sunday. But let's take a look at the next couple of days in our extended forecast. So just to recap on the weekend, cloudy with some PM snow expected for Friday, 42 for our high, so well above average, before dropping down to 28 once that front passes through our area. By Saturday and Sunday, we'll have a mostly cloudy sky for both those days with a 34 for our high, and that's right about average for this time of year, lows dropping into the mid-20s. If we want to look at our extended forecast for our next work week, we can see our average for this time of year is between 34 and 35, so we'll be sitting right around average for the next couple of days. We'll see some rain on both Wednesday and Friday, otherwise cloudy conditions by Monday and Tuesday. Thursday, the sun will peak out for a little bit, and then Friday will warm up around 38 degrees expected for our high on Friday, but again, we'll have a chance for some rain-snow mix. Now let's hear our Weather Whiz Quiz question answer.
And now time for your Weather Whiz Quiz question. What was the total cost for weather and climate events in 2020? Was it A, $36.2 billion, B, $46.6 billion, C, $53.8 billion, or D, $54.1 billion?
The correct answer is B, $46.6 billion. In fact, the most expensive event from this year was Hurricane Laura, which cost $14.2 billion alone.
Wow, that is really a lot of money from one year of weather. And from all of us here at Weather or Not, I'm Joe Rook.
And I'm Salix Iverson. Have a great weekend.